Hello, everyone. This relationship that you see here is what AI used to solve geometrical puzzle. And I promised to do a quick video about this. And there are two components of vector W, and they are written as some sort of weighted average of two vectors u and v. And so let me show you how you can use this idea to simulate the vector W. And when we change the alpha, we can get many vectors. Now, let me try to put it at 0 and then show you some segment of length 13. When alpha is 0, the vector starts at the beginning of the segment. And then as you go with alpha higher, you can get all different vectors that have the head at different locations of this segment. And so you see just the parameter going from 0 to 1, it covers the entire segment. Now this is completely arbitrary, how long segment you want to cover, but you have to understand how to get the alpha. So this video will demonstrate how this things is done. So let me take this away and just start with point A at the origin, and then vector u and vector v. Those two vectors will be used to find the linear combination of those two, and we call it W. But first, let me explain how you can find this vector B. So this vector connects the heads of arbitrary two vectors, u and v. And if you take the difference of those two vectors, you get this green one. It's probably the key to understand why this is the case. And I think the best analogy and that can work for any vectors is to use the vectors as displacement vectors. When you walk from the origin along the vector, you reach this destination here at the end of the vector u. Then you continue along the vector that is the green vector, and you finish somewhere at the head of the vector v. And that means that u plus the vector that is the green vector should recover the vector v. And that's what this algebra says, that if you take u plus v minus u, the u cancels out and you end up with v. And this simple observation is quite powerful. Now, once you understand that, then you can add vector w and ask the same question. How would you find vector that connects the head of u and w? The w is the second one, as the v was the second one. And that's supposed to be this first vector. And then you have to just subtract the one that is the starting vector. That means you start the motion from the head of that. So I will show you that the green vector, take the green away and show you the vector that just combines that. So again, it's all about knowing the relationship between this one and this one. That's the catch. And again, you can see that the red one is just short version of the green one. So let's start with the green, and that's the equation. Then, let me put it a little bit higher. Then we will get the red one. That's in analogy to the green one, the same thing. So v minus u or w minus u. But now comes the catch. We know that this green one is longer version, so we just multiply the green vector by some number less than 1, and we get the shorter vector. And the only question is, what's the alpha? And that's probably not that hard to see, maybe we can just get a little bit help. If I show you that the length of the red one, of the red vector is 5, so 5 units long. The green one is 13, so I will just show you that the complement here is 8 units long. So we have 5 plus 8. And if you need just this piece, that is essentially 5 over 13 units, right? 5 over 13 is the ratio of the total vector. And this complement would be 8 over 13. So we see those ratios. So what is the alpha? Now you have to just convince yourself about the right value. And here is what is the statement, that if you choose alpha 5 over 13, you get the right number. We can kind of see it over here, that here we have the 13 units, and you want to end up with 5 units. So the alpha is just 5 over 13. The 13 cancels out, and you are left with 5. So that's pretty straightforward. And to finish, it's not any harder. We just need to figure out the W itself. That means we need those points over here. I can even show you what values are there. So at this point, we have 7, 6. Okay, so the question is, how do you get that 7, 6? Do you see that's the first vector over here? It's 7, 6. That's where the head of the blue vector is. And so right now, I think I can just write the answer and we can just see if that makes sense. So the answer is over here. I will place it below. And here we see that the Wx, that means this first component of the vector VW, is when the u vector is on the other side of the equation. And so we can quickly see that alpha times minus u is minus alpha u, but then plus this u. And that gives us something important. I will show you this equation here. It gives you 1 minus alpha times u. On the other hand, there is only alpha times v. There's nothing, no more v's. So that's this part. So again, this u from this side has to be moved to the right and then added together with alpha times minus u. That's this portion, alpha times minus u. And then 1 times u is u that came from the left-hand side. So I think this is very clear. Just write it down carefully. And just to see, here is the alpha, 5 over 13. And that is the component that goes to the calculation. 1 minus 8, I'm sorry, 1 minus 5 over 13 is 8 over 13. And then once you have this linear combination, you can just write it as a singular ratio where you have 5 units, 8 units, and the denominator, of course, is just 5 plus 8. And that was the form of the equations used by the AI to finish the puzzle in geometry. And so why that special sophisticated thing has to be used? Well, it doesn't, but it is a very general rule. And the AI is probably trained to use the very powerful tools from linear algebra and tries to utilize them whenever possible. So just to demonstrate that, when you take this origin and move it, nothing changes about alpha. Let me put the alpha on top of the equation. So it's independent of the origin. That's one thing. So you can put the origin directly here. You can put the origin wherever you want. So that's one piece of freedom, but it's even more general. You can move this and make it at any angle you wish, and then you can move this one to any proportion of the distance between the head of u and head of v. So again, you can move it around as you wish. the formula still stays the same. And you see it's getting just more complicated, but you always know where this point is. So thank you for watching, and I hope you will play with this concept. The main result is that this linear combination that is used in many parts of mathematics. Have a nice day. Thank you for watching.